We all grew up on the same lie. Star Trek, Star Wars, Interstellar. Beautiful ships, warp drives. Brave captains sipping tea while staring at the Andromeda galaxy. Elon Musk sells us the dream of Mars. NASA shows us pretty renders of colonies. We look up at the stars and think, we'll be there soon. I don't want to be the guy who ruins the party, but we aren't going anywhere. Space isn't an ocean waiting for Columbus. Space is a sterilization chamber. It is a place where physics, biology, and time have combined with one single goal: to expel you. Today, we're taking off the rose-colored glasses. We're cutting the sci-fi and keeping only the dry, brutal facts from bio-physicist and engineer reports. I'm going to give you 5 reasons why humanity will likely stay in its cradle forever or perish trying to climb out. And the last reason, that one is the scariest, because it's not about tech, it's about who we are. You're driving down the highway. A pebble hits your windshield. Annoying. Now, imagine that same pebble. But you're flying at 28,000 kilometers per hour. At that speed, the pebble doesn't make a crack. It works like a plasma cannon. In space, there's no such thing as a fender bender. There is only hypervelocity impact. When the speed is that huge, even a speck of dust turns into a stick of TNT. In 1983, a grain of sand, literally a paint fleck 0.2 millimeters wide, hit the window of the shuttle Challenger. If it had been the size of a pea, it would have shot through the astronaut, the seat, and the ship's hull. And now, look up. We've trashed the orbit. It's called the Kessler Syndrome. Donald Kessler, a NASA consultant, predicted this back in the 70s. There are millions of debris pieces flying up there right now. Old satellites, rocket stages, nuts, bolts, screwdrivers dropped by astronauts. It's a swarm of bullets flying in chaotic directions. Launching from Earth right now is like running across a superhighway blindfolded during rush hour. But let's say we broke out. We're flying to the stars. The interstellar medium isn't empty. There's gas, dust, and micro-asteroids. If we boost our ship to at least 20% the speed of light to get to the nearest star in 20 years, a normal hydrogen atom hanging in the void turns into hard radiation at that speed, bombarding the hull, and a dust mote weighing just 1 gram, hitting at 20% light speed, releases energy comparable to a tactical nuclear explosion. How do we protect ourselves? If we add armor, the ship gets too heavy to accelerate. We are a crystal vase flying through a hail of bullets. Let's say we have a super shield. We made it through. But inside the ship, something weird starts happening. Apollo astronauts on their way to the moon complained about one creepy thing. They would close their eyes to sleep, and in total darkness, they saw flashes. White streaks, dots, explosions of light right inside their eyeballs. You know what that was? Those were particles of galactic cosmic rays, GCR, flying through the ship's hull, through their skull, through their brain, and hitting their retina, causing a false signal. Radiation was shooting through their brains. On Earth, the magnetic field and atmosphere protect us. On the ISS, astronauts are still under Earth's magnetic shield. But the moment you leave orbit, you're in a microwave. There are 2 critical things: solar flares and galactic rays. If the sun sneezes a stream of protons at you while you're in a tin can on the way to Mars, you get a lethal dose in hours: acute radiation sickness, vomiting, organ failure, end. Galactic rays. These are heavy element nuclei iron, nickel accelerated by supernovas somewhere far away. They fly at nearly the speed of light. They punch through everything. Lead, water, plastic. When that particle hits your DNA, it shreds it, like a shotgun. A study on rats at UC Irvine showed something terrifying. They radiated rats with doses similar to a Mars trip. The result? Space dementia, brain inflammation. Neurons lost connections. Rats stopped recognizing new objects, lost their memory, started panicking. By the time our crew gets to Mars, they might just forget how to land the ship. They'd turn into vegetables, or go insane from paranoia. And we still don't know how to shield against galactic cosmic rays. Maybe lead? It makes it worse. The particle hits a lead atom, shatters it, and instead of one bullet, you get a spray of shrapnel as secondary radiation. But the main problem with space is, it's big. No, you don't get it. It's stupid big. The human brain can't comprehend these scales. Let's break it down. The fastest object humans ever launched into interstellar space is the Voyager 1 probe. It's been flying for almost 50 years. You know how long it would take to get to Proxima Centauri if it was headed there? 75,000 years. We live 80 years on average. Space is telling us, you guys die too fast. Even if we invent a fusion drive, even if we hit 10% light speed, which is sci-fi right now, the trip takes 40 to 50 years. You get in the ship as a young guy. You arrive as a senile old man. And that's just the closest star. There are billions in the galaxy. What about other galaxies? Andromeda is flying at us, but right now it's 2.5 million light years away. Light, the fastest thing in the universe, takes 2.5 million years to get from there. That's not travel, that's archaeology. If we fly there, by the time we arrive, humanity on Earth might be extinct. We are locked in. Physics gave us a speed limit, the speed of light, that turns the universe not into a field for exploration, but into a museum where all the exhibits are behind bulletproof glass and you can't touch them. Okay, you watch sci-fi. They say warp, drive, hyperspace. Let's stay within real physics. Let's say Einstein is right. Faster than light is impossible, but almost light speed is possible. We need massive acceleration, and here our body comes into play. We are soft, wet bags of meat and bones. The show The Expanse showed this cool thing. Pilots get injected with juice, so they don't die from G-force. In reality, there is no juice. If a ship accelerates too fast, you black out. Your blood becomes heavy like mercury. The heart can't pump it to the brain. In hours of constant acceleration, you turn into pate on the seat back. To survive, we need to accelerate slowly. A comfortable 1G like Earth gravity, but then getting up to speed takes months and years. We hit the time problem again. And the funniest part, braking. There is no friction in space. If you sped up to half light speed, You need just as much energy and time to brake at the destination. You can't just hit the brakes. You have to flip the ship and blast the engine the other way. That means you accelerate for half the trip and brake for the other half. No quick jumps. It's long, boring math. And if you miss, if the engine fails during braking, if you fix it too late, you fly past the target at 150,000 kilometers per second into eternal darkness, and no one will save you. You fly forever until the oxygen runs out. We talked about rocks, radiation, time, but there is something scarier. What happens to us just by being there? We evolved for 4 billion years. Every cell, every gene is tuned to one specific place. Earth, gravity, atmospheric pressure, magnetic field. The moment you remove those conditions, your body starts self-destructing. NASA did the famous twin study. Scott Kelly spent a year on the ISS. His brother Mark stayed on Earth. When Scott came back, scientists were horrified. He wasn't quite the same person. In zero-G, fluid rushes to the head, intracranial pressure rises, it pushes on the back of the eye. Eyeballs get flattened. Astronauts lose vision, and it can be permanent. Zero-IP syndrome, bones and muscles. Without gravity, the body thinks, why do I need a skeleton? I'm not walking, and starts dissolving your bones. Calcium gets peed out. You lose 1 to 2% bone mass per month. After a couple of years flying to Mars, if you try to step on the planet, your legs will just snap under your body weight. But the scariest part is the microbiome. We aren't alone. Trillions of bacteria live inside us. They help digest food, protect us. They are used to Earth rhythms. In space, in a closed box, with radiation, bacteria start mutating. They get aggressive. Your own symbionts might start eating you from the inside. We are built for Earth. We are part of this biosphere. We aren't travelers. We are a tree trying to rip up its roots and go for a walk. A tree can only do that if it becomes firewood. Maybe the great Fermi filter isn't nuclear war or evil AI. Maybe the reason we don't see aliens is simple. No one can leave. Distances are too vast. Biology is too fragile. Radiation is too deadly. All civilizations are born on their planets. Look at the stars, dream, locked in their golden cages. But you know what? We'll try anyway, because we are humans. We are stubborn, and we love doing the impossible. The only question is, God, how many sacrifices will we have to leave on the road to the red planet to realize space doesn't want us? What do you think? Can we ever cheat biology and physics? Or are we Earthlings forever? Let me know in the comments. This was Space Unlocked. Keep your helmets on.